The first question is, what is a data structure? See, we have different types of data like int and float and character. Okay, so the organization of those data in the memory is nothing but data structure. We have two types. First one is primitive and second one is non-primitive. In primitive, we will have the single entities like int, float, char and double. Okay, in non-primitive, we will have multiple datas and which is further divided into two parts, linear and non-linear. In linear, we will have the data stored in a sequential order like array and linked list, and in non-linear we will have the data in a graph type. Okay, so those include trees and graphs. And coming to the data structure operations, we have the four major operations, which is traversing, which means accessing each element one by one, and searching means searching for a specific element, and insertion means inserting a new element, and deletion means we are removing a particular element from the group. Okay, what is a structure? See, normally we have variables to store just integer values or the character values. Okay, but in structure you can store both integer and values together. Okay, so let's see the syntax. The syntax is as follows: struct student. Okay, it will have char name or whatever variables you want to store in it. Okay, so this will create a memory allocation here, which will have the name and age and roll number. Okay, so these three things will be in a single entity. That's the advantage of structure. And how is it different from array? In array you will have the different elements, means in array you will have the same elements, like all will be integers or all will be characters, but in structures you can have different data types. Okay, and there are two ways to declare a structure. First one is declaring a structure here and then initializing the object before ending the declaration. Okay, and in second one you will declare the structure and then initialize the object separately. Okay, what's the difference between a structure and a union? The syntax will be same for both, but the declaration part means in the memory allocation you will have different spaces for the variables used. Okay, in structure, while whereas in union you will have the same memory allocation for both of these used, and at a time you can store either integer a or char b. Okay, what's a pointer? Suppose that there is a variable here and it has a memory address, and that address is stored in another variable that's known as a pointer. Okay, so the declaration will be of this type. If you want to store a address of integer variable, you will use int star pa. Star denotes the pointer, and the initialization will be pa is equal to ampersand a. Ampersand will return the address of the variable. Okay, that will be stored in pa. Dynamic memory allocation means during the runtime, means after when we are executing the program, at that time the allocation of the memory which happens, that's known as dynamic memory allocation. Okay, and there are four types. First one is malloc. See, in malloc the syntax is as follows: int star malloc 10. So if you use this syntax, at that time 10 bytes of the memory will be allocated. In calloc it's the same thing, but it will be having divisions. Like if you initialize calloc 5,2, that will allocate 5 blocks of memory, each of size 2 bytes. Okay, and realloc means if you want to change the size of the memory from 10 bytes to how many bytes you want, you will use realloc. Okay, and free means if you have used the pointer and you don't need that anymore. If you don't need the pointer anymore, you can use this free operation to deallocate the memory. Okay, this is a very important question. Please pay a lot of attention here. Explain KMP algorithm. Okay, see, this question I have explained in my theory part of the video of data structure module 1. Okay, in very detail. So if you want, you can refer that. I'll go through very briefly in this video. So first our step is to make a pi table. Pi table means where all the letters are repeated, that one we will write the numbers here. Okay, after that what we will do is we will search for the similar repeating elements. See, first we will check for a and a, it's same, so we will move on. Then b and b, like that, c, c. Then the mismatch happens here, d and x. At that time where we will start the searching again from, we will see the previous element here, which is 0. So we will start the searching from here. Then in the 0th location a is present, right? So a will be compared with x. So a is not matching with x, right? So what we will do is we will start from the next part, like a. Again we will compare these both. Like that we will go till here. If this pi table ends here, so that means the text exists in the main text. Okay, so the pattern exists in the main text, or else it doesn't exist. Okay, concatenation means we are joining two arrays, and what we will do is we will travel till the end of the first array, then we will copy this array after this first array gets over. Okay, that's known as concatenation. In reverse of the two strings, what we will do, see, first we will take this letter and put in the first place, then the second last and the second letter, like that till we reach the middle letter. We will be doing the same thing. Okay, that will produce the reverse of the array. Okay, sparse matrix means a matrix in which the zero elements will be more, okay, more than 50%. So that's known as a sparse matrix. And in sparse matrix, how can we represent it? We can represent it by using an array. Okay, in array we will have the rows, columns, and the value space here. So in the rows we will mention how many rows are there, means see here. In this sparse matrix we have 6 rows and 6 columns, and how many non-zero elements are there? 8 non-zero elements. Okay, so we will count that, and after that we will mention here. This is an array. By using a structure we created array. In that we will have 3 columns here. Okay, first one is for rows. In the first row what we will write is how many rows are there in that matrix, how many columns are there, how many non-zero elements are there. After writing that, we will start from the next row. The first non-zero element, 15 is the first non-zero element, so 0 and 0, rows, row number is 0, column number is 0, and value is 15. So we will write here 0, 0 and 15. Then for the second one, which is the second one, 22, it is present in row 0 and column 3. So we will write here 0, 3 and 22. In the same way we will do for all these elements and store it in a array. Okay, after doing this your array is ready. Next what we have to do is find the transpose of it. Okay, transpose means, see here, this is the array here. If you want to, this is the matrix here. If you want to find the transpose of a matrix, what you will do, first you will take all these elements in the first column, that will be stored as a row. Okay, means in the first row you will have all these elements, 15, 0, 0, 0, 91, 0. Okay, so see here, this is the first row. In second row what you will have, all these columns, all these column values. Okay, this will be stored as second row. Okay, that's known as transpose of a matrix. Okay, now how to after finding the transpose, we have to store this transpose in an array. Okay, like for before we stored normal sparse matrix an array, like that we will store for transpose also. Okay, in this what we will do, we will see from here which all elements are present now. In different location it will be present, so that we will be noting down here. Okay, in this array. Now you have to write a program also for this. First one is, see here, it's divided into two parts. First part you will initialize the first row, which is 0th row. Okay, that one will be b of 0 dot row is equal to a of 0 dot column, and columns value will be row. Why? Because we found the transpose, right? So the initial array was initial matrix was this, it had this many rows. Now this row, this column got converted into this row. So how many number of columns will be there? That will be same as the number of rows here. Okay, so in that way columns and rows will be interchanged. So in the first two lines what we will write is b of row is equal to a of column, and b of column is equal to a of row, and value will be same because the number of elements of non-zero will be same. Okay, so we will start from here. We will use two for loops. In this each for loop what we will do is a of j dot column is equal to I. So see here, this is a array. Okay, this is the a array. In this a array first what we will do, we will find the column 0 and 0. These columns are represented as the rows now, right? The first 0th row we will store these values 15 and 91 in the first row. See here, in transpose 15 and 91 is in the first place, right? So that will be stored in the first row. Like that, next what we will do, we will increment j here. See, j value will be incremented. So a of j dot column, j will be 1 now. Okay, before j was 1, now j will be 2. Now a of 2 dot column, what is a of 2 dot column? See here, a of 2 dot column, this will be checked. Okay, again this all will be checked here, which is equal to I. What is I? I is 1. Now we will see for 1. This one will be selected because 11. See here, this element 11 is present in the first row of the transpose matrix. In that way we will check for each row, and then we will store that in the array. Okay, that's the transpose of a matrix. Okay, consider two polynomials a of x and b of x. Now we have been given this polynomial, we have to find out how to store in a 1D array. Okay, a 1D array will have two rows. In the first row we will store the coefficients, and second row will store the exponent. So in this, what's the coefficient? 4 is the coefficient, 3 and 5. So that will be stored in the top row. In the bottom row, what is 4 having the exponent 15? 15 will be stored, and 3 is having 4. So below 3, 4 will be stored, and 5 into x power 0. Okay, so 0 will be stored here. Like that, similarly for B also you have to show, and you have to give us. They have asked to give the C representation. Okay, means what structure you are using. Means in this structure we will have three things. In this structure we will have two things. First one is float for coefficient and int for exponent. Okay, write a function to add two polynomials. Okay, first we will take what is CF1 and PX1. Okay, that means from that array the first element will be taken, its exponent and coefficient value. After that we will search that element in the second array. Okay, so that two polynomials were there, we are searching that particular element's coefficient in the second one. Okay, if we get it, then we will add the coefficients. Okay, if we don't get it, we will write it as it is. Okay, so we are finding the sum here, coefficient of 1 plus P2's coefficient. Okay, after doing that we will find the sum, and that sum will be written in the resultant polynomial. Okay, else if the coefficient is not found, means the exponent values were not found in the other array, what we will do is CF1 is copied into P3. Okay, and Px1 is copied into Px. Okay, means in the final array the coefficient value will be stored in the coefficient part, and the exponent value will be stored in the exponent part. Okay, what is a stack? In stack, that's an array, but we can insert and delete the elements only from one end. Okay, and we have four operations, which is push, pop, overflow and underflow. In push we will insert an element, and in pop we will delete the element. Overflow means in case the stack is full, means all the spaces are filled by the elements, so that's known as overflow. In underflow, if the stack is empty, that's known as underflow. So the C program is for push. First you will check if top is equal to size minus 1. That means if this is a stack, size minus 1 will give the top element. Okay, if the top element is stored here, that means the stack is full. Okay, that will printf stack overflow. In case the stack is not empty, at that time we will take an item by using scanf and we will insert it into the empty space. Okay, that's a push operation. In pop we will check if the stack is empty. If it's empty, we can't delete the element, it will show the stack is empty. If there is an element here, at that time we will printf which element is getting deleted by this statement, and will do top minus minus, means if top is here, top will become the previous location. Okay, that's pop operation. And the next one is empty. We are checking if the stack is empty by seeing the top position. Okay, if it's minus 1, that means stack is empty. Similarly for full also we will see if top is equal to size minus 1, that means stack is full, and it will printf stack is overflow. Okay, in this question we have been asked to write the postfix form of the following expression. Okay, in the first case how we will start is we will draw three columns: symbol, postfix and stack. In stack we will just store the operators like hash or bracket or subtraction sign, multiplication sign, division sign. Those things will be stored in stack. In postfix we will store the first alphabets, and after that if it gets popped from here, that time we will store the operators. Okay, so we will start from here. First one, two brackets are there, so we will store the brackets inside this stack. After that a is there, a will be stored here. Then division sign, division sign will be stored inside this stack initially. Then after that b is there, so a with b, then minus it will be, see, you have to know the priority scheme. Okay, this is the priority scheme, and the rule is if this scanned symbol which is minus, okay, that minus has the equal or less priority than this one, at that time this will be replaced here. Okay, see, minus where it is here, and the division sign which is here, so minus is having less priority than this division sign. At that time this division sign will be popped into the postfix. Okay, and the minus will be here. Okay, and like that only for all these next iterations we will do the same thing. Okay, for each alphabet, and we will get the final result here. Similarly we have to do for the second question also. Okay, If you want more information on this, I have discussed in detail in the theory part. Okay, you can watch that video. So in first case we will draw 4 columns. We will have the symbol, operand 1, operand 2 and stack. So the steps which we follow is, if we have the symbol here, that will be stored here. Okay, all those symbols will be stored in stack first. Then if an operator comes, at that time what we will do, we will pop the previous 2 operands, which is 6 and 3. So what is 6 divided by 3? It's 2. So we will store the 2 in the stack. Okay, like that we will do for all these elements. Okay, we will get the final result as 15. Recursion means it calls itself. Means suppose that there is a function and it has a set of line of codes, and inside this code the same function is called again, which is function. Okay, so that's known as recursion. So we have to write the code for factorial of a number and tower of Hanoi. Okay, so in factorial of a number you will call the function itself and you will have n into fact n minus 1. Means what's a factorial? Basically factorial means if it's 3 factorial, that means 3 into 2 factorial. At that time what you are doing, n into n minus 1 factorial. So return n into fact of n minus 1. You are again calling this function and finding the factorial, and that will be returned here. Okay, so the same thing is with tower of Hanoi. In tower of Hanoi you will have all these like set of disks here. At one time you can just move one disk, and some set of rules are there. Okay, so this is the code for it, and this also recursive function because you are calling the function which is tower 2 times in the this function void tower. Okay, so this is an example of recursive function. In this question we have been asked what's the advantage of circular queue over ordinary queue. In suppose that this is the queue. Okay, now there are elements from here 1 2 3 and 4. Okay, now in ordinary queue you can just insert the elements from this end and delete from this end. Now if you want to insert any new element, you can't insert because it's the end of the queue. So what you will do is, in circular queue you can travel to back of this array, and you can utilize this space to store the new element. Okay, so that's the advantage. So in this question we have been asked to write the codes for insertion, deletion and display. Okay, so here are some codes for insertion. What you will do, first you will check if count is equal to size. At that time queue is full. If it's not full, what you will do, you will increment to the next location. So the line of code for finding out the next position is r is equal to r plus 1 percentage size. Okay, by that you will get the next location. In that next location we will store the item. Okay, similarly for deletion also, if queue is empty we will return, else the deleted element will be printed first and the front pointer will be incremented. Okay, by using this line of code. Display is very simple. There are elements, it will be traversed one by one and the information part will be printed. Okay, in this question they have asked us what is linked list and explain the different types of linked list with diagram. Okay, so basically what is a linked list? In linked list you will have the nodes here. Okay, and in nodes you will have 2 parts. First one is information part and link field. Information part will have the data and the link field will point to the next node. Okay, in this list we have 4 type of linked list. First one is singly linked list. In singly linked list we will have the main node here which will be pointing to the nodes in the list. Okay, so this will be in a sequential order and each node is pointing to the next node. Okay, so it's called as singly linked list. The second one is doubly linked list. That's also same, but it will have the address location of the previous node also. So each node will be pointing to the next node as well as previous node. Okay, in circular singly linked list you will have the last node pointing to the first node, and in circular doubly linked list you will have the previous node's connection and next node connection. Okay, and it's circular, so last node will be pointing to the first node and the previous location of first node will be pointing to last node. Okay, in this question we have to write the C program for the following operations. Okay, first one is concatenation. That's the same as for singly linked list. See, if you have this list here and another list is here, so if you have to concatenate you have to store the value of this in this address and the value of this in the previous location here. Okay, so that's what we are doing in this code. For searching an element you will travel each element and you'll check the information part of it. If you get the information, if it matches, then that means the element is present, and you will printf that the element is found. Suppose that this is the linked list. If you have to insert at the beginning, the left part of the first node will point to the newly created node, and the right part of this node will point to the first node. Okay, in that way you can insert at the beginning. Delete at the end means we will have two pointers. First one will be pointing to the current location, and this will be pointing to the last location, means previous one. When we reach the last node, at that time, see here, when we reach last node, the current pointer will be pointing here and the previous one will be pointing here. At that time we will free this pointer and we will initialize the next part, which is the right part of it, as null. Okay, since this node is removed, this will be null here. Okay, that's deletion at the end. If you have to insert or delete a block at the specified location, what we will do is, for insertion, first one will travel which location we have to insert. At that location, the next part of it will be, the right part of it will be pointing to the newly created node, and the left part of this node will be pointing to this one. Similarly for here also, the right part will point to the next node here, and this left part of this will point to the previous node here. Okay, by doing that we can create a connection between all of these nodes. Okay, similarly for deletion also, if you have to delete this node, that means the next part of this should point to this, and the previous one should point to this. Okay, so that's for the deletion purpose. In this question we have been asked to write the advantage of doubly linked list over singly linked list. In doubly linked list we can traverse both in forward and backward direction, so it will save a lot of time. Also, if you want to insert and or delete the node, it will be very easy if it's the previous node, because we have the previous pointer. Okay, so you can just directly travel to the previous node and insert or delete the new element. Okay, see here, if this is the linked list, two linked lists are there. If you have to add the polynomials, okay, first what we will do, we will check this coefficient. If that coefficient matches in any of these, that at that time we will add the coefficients and store in the resultant variable. If it doesn't match, we will add this variable to the resultant one, and the remaining variables here will be also added to the resultant one. Okay, in that way we will add two polynomials. For the given sparse matrix, give the diagrammatic linked representation. So this is the sparse matrix which we have been given with, and in the first what we will do is, see here, count the number of rows and columns. We have 4 rows here and 5 columns here. For the linked representation, first we will make a box here and write the number of rows and columns, which is 4 and 5. And in the third space, what we will write is how many non-zero elements are there. 4, 6, 5, 3, 1 and 2, means 6 non-zero elements. So we will write here 6. Okay, and how many columns are there? 5 columns, right? So we will make boxes till 0 to 5. Okay, and the rows will be made here. Now see, the first non-zero element is this one. Where is this 4 stored? In the 0th row and 3rd column. That means 0, 2. Okay, so in the 0th row and the 2nd column, this will be stored, and the row number which is 0 and the column number which is 2 and the value, that will be written here. Okay, like that we have to do for all of these. After doing for all of this, what we will do is we will make these connections. See, look here, first connection will be made here, okay, to the column, and this will be connected together. Okay, similarly for all other elements also. In this question we have been asked to write the function in C for singly linked list. Okay, first one is reversing the linked list. See, in reversing what we will do is, if this is the linked list, at that time we will change the direction of this each connection. Okay, means if this is pointing to this, we will change it to point to previous one. Okay, that will reverse this list. Second one is concatenating two lists. Okay, so the concatenation will be as follows, same as the previous one. Two lists will be there. We will just travel to the last node of this list, and we will join with the first node of the next list. Okay, the third and the fourth one is finding the length of the list or counting the number of nodes. Both have the same function. So for that we will travel each node. See, if this is the list here, we will have if we have 4 nodes here, we will travel each of this node for keeping a count of how many nodes are traveled. Okay, So we will be incrementing the count by one value after traveling each node. So when we reach the end, at that time we will stop the count and we will come out of this function and will return count. Okay, that will return how much is the length or how many nodes are present inside this list. Okay, searching the element is also same. We will have the list, we will travel each list and compare the information part with the item. Okay, so item is int key, means which value they give, that will be compared with the information part of each node. If we get that, we will come out of this function and we will print it that it's found, else if we don't get it, we will print as search unsuccessful. Okay, in this question we have been asked to create a linked list with the values 15, 25, 40 and 50. So for that, first we will declare the structure part, which is having the information and link part, and after that we will use this function. Okay, in this function first we will create a memory allocation and we will use a for loop. In for loop we will travel from 0 to 3, means we have 4 nodes here, each will be traveled for one by one, and we will ask the user to enter the information, which means first the user will enter the numbers which are asked in question, these numbers 15, 25, 40 and 50 at each iteration. Okay, that will create the list with the values 15, 25, 40 and 50. Okay, in the next question we have been asked to insert a node with the data value 30 between the nodes 25 and 40. So first we will create a node with the value 30. So for that we will allocate the memory, and temp arrow info is equal to 30. So we have this 30 here. Okay, a new node. In the previous linked list we had 25 and 40 here, and the rest of the elements are here. So if you have to insert this 30 here, what we will do, we will initialize the next part of 25 to 30 and 30 is linked part to 40. Okay, so that will insert 30 in between 25 and 40. In the next question we have to delete a node with the data value 40. So for that we will travel till when we get 40 and we will use free to delete that node, and previous arrow link means if this is the list here and the 40 is here, previous will be pointing to, suppose that it's 25. So we have to make the previous link, see here 25 is here, and this node if you delete, the next node of it should be pointed by the previous node. So that's it, temp arrow link will be pointed to previous, temp arrow link. Okay, that will be pointing by previous. Okay, so in that way we will make a connection. If it's null here, at that time this will be stored as null. Okay, and by using free temp we will delete 40 from here. In the next question we have been asked to search a node with data value 25. So we will travel each node and compare the information part. If we get 25, we will print the element is found, else we will print element is not found. Tree is nothing but a type of data structure in which we will have the root and the nodes connected by branches. Okay, what is a binary tree? In binary tree you will have two subtrees for each node. Okay, that's known as binary tree. You can have one node also, but at most only two you can have, three you can't have. That's a binary tree. In strictly binary tree you will have all the nodes as 2. See here, in strictly binary tree all the nodes will have two subtrees. Okay, that's strictly binary tree. In skewed binary tree you will have either only the left nodes or the right nodes. The level of a binary tree is given as from the root node how many branches you have to travel to reach the particular node, that's the level. And in complete and almost complete binary tree, the last level it's not mandatory that it should be filled. Okay, and the filling should happen from left to right. That's complete binary tree, and almost complete is also similar to it, but few technical differences are there. Okay, and degree of a tree is means if I talk about the degree of the root node, it's 2 because it has two subtrees, and the degree of this is 0 because it's a leaf node, and the degree of this is 1 because it has one subtree. Okay, write C functions to traverse the tree using pre-order traversal, post-order and in-order. So suppose that this is the tree, and in this tree we have to travel using first pre-order. Okay, for pre-order remember it is N, L, R. N means node, L means left and R means right. So we will start from here, we will print this node. N means we will print this node, then we will move to left, then we will print this node, we will move to left, we will print this node, then we will see if left is there or not, then right is there or not. If it's not, we will move back here, then we will go to right, then we will print this and we will move back here, and we will do the same thing for here also. Similarly For post order it is L R N. First we will move left, then right, then at last we will print the node. And for in order it is L N R. Okay, so the same things are here. See, it's pre-order. Pre-order is N L R, right? So N L R. N means print the node, and L means L link, R means R link. Okay. Similarly for post order and in order also. In this question we have been asked to draw a binary tree and give the array and link representation of the same. Okay, so first we will draw a binary tree. For drawing the binary tree, consider this as root node. The first one, it's 100. Okay, then next is 85. If the this element which is 85, it's less than 100, right, we'll put in the left position. If then we'll consider 48. We'll start from here. 48 is less than 100, we'll move here and we'll check with 85. It's less than 85, so we'll place it here. Okay, then 55, it's less than 100, less than 85 and greater than 48, so we'll move here and put here. In that way we'll complete all of these elements in the binary tree, and the array representation is in this way. We'll start from here, 0th element, then 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th and 10th. In that way in array we'll represent it, and link representation is the same as the circles we had there, but in the in this part we'll have the left link and the R link, which is pointing to left and right subtrees. Okay, this is the link representation. What is the advantage of threaded binary tree over binary tree, and explain the construction for the binary tree. Okay, now see, the advantage is that in normal binary tree we'll have more wastage of space because the links of null part is not utilized, and the time is also more consuming, and only downward movements are possible. But in threaded binary tree you can move upwards also, and computation of the predecessor and successor is time consuming because we won't have the link part for the predecessor and successor. But in threaded binary tree we'll have the predecessor and successor links. Okay, so that's more easier. And the binary tree, if we consider it as 30, we had the elements from 10 to 50, so 20 is less than 30 and greater than 10, so we'll place it here. Okay, similarly 40 and 50 will also be placed. In this question we have been asked to define expression tree and traverse this tree using in order, pre-order and post order. This is same as the previous one as I had discussed, and the difference lies in what is expression tree. In expression tree you will have the operators and the operands placed here, and it should satisfy three conditions. First one is any leaf is an operand. Leaf means the last nodes. Okay, all the last nodes here are operands. Okay, and the operators will be the root node and the internal nodes. Okay, and the subtrees and the subtrees means see here. In subtrees also the same rule applies. If this is the subtree for this node, and this node also has this root node as operator and the leaf nodes as operands. Okay, the same thing applies for all the subtrees. In this question we have been asked to construct a binary search tree for the following pre-order and in-order traversals. Okay, so we have been given with both of these, and we have to create a binary search tree. For the construction purpose, first we will look at pre-order. In pre-order we have NLR. Okay, that means always we will start from the root node, right? So A will be the root node, so we'll write here A, and we'll see the same in LNR, which is in order. In order A is present here, that means this is left part L and this is right part. So in left part we will make B and C, and in right part we will make E, D, G, H, F and I. Okay, so in the same way we will do for the next one also. The next node is B, so after A, B will come here. Okay, then after B, C is here, so C will come here. This ends the left part of A. In right part, observe here D is coming first, so D will be here. And in order we will check where is D. D is here, so the left part will have E and the right part will have G, H, F and I. Okay, so we'll make E here and we'll make the remaining, which is G, H, F and I here. Okay, now which to choose among G, H, F and I, we'll see from pre-order. After E, F is coming first, so F will be here, and we'll see in order where is F. F is here, so in the right part of F I is there and the left part of F H is there. So in the left part of H, G and H will be made and I will be made here. Okay, then we'll see which is coming first after F. G. G will be here, then H, and I is already present here. So this is the binary search tree. In this question we have been asked to create an expression tree for the postfix expression given below. Okay, and traverse using in order, pre-order and post order traversals. Okay, now see, if they have asked to create an expression tree, first we need to convert postfix expression into infix expression. Okay, for the conversion we will make 4 columns. In the first one we will have symbol, and we will write one by one all the symbols in which the expression was given to us. Okay, so this is the expression, we will write each symbol one by one in each row. Okay, and we'll have here operand 1 and operand 2. At last we'll have stack. Now how to convert? First we will scan each symbol. A will be written in the stack, okay. B will also be written in the stack. Now if an operator comes, at that time we will select these two operands. The first one will come here, the second operand will come here, and we will apply this operand operator on this both operands, okay, and we will write the result here, which is A divided by B. Then we have C here, so we will write C with this. Now A by B is considered as a single unit, and we have the multiply sign here, so A and B will come in the first operator and C will come in the second operator, and we will write the result here, A divided by B into C. So that will be written here, and this will be considered as a single unit. Now like that only, moving on till the end, we will get the final expression. This is in the infix expression. Now after getting in the infix expression, we have to make the expression tree, okay. Now see here, this is one unit and this is one unit. The both of these units are connected by plus. So we'll make the operator first, okay, because in expression tree the root nodes and the internal nodes are the operators. So first we'll make plus here, and right side of plus is E, right? So we'll place E here, and this whole part will place here, okay. Firstly we'll place here, then we'll apply the same rule for this also, and finally we'll get this expression tree here, okay. In this question we have been asked to write a note on threaded binary tree and insert R as a right child of S in threaded binary tree, and also we have been asked to write the function for it. Threaded binary tree is nothing but the null links can be replaced by the pointers, which is having the successor or the predecessor of the given nodes, okay, that will be stored in the null links. We have three types of threaded binary tree. First one is in order. In order we will store the elements in order way. So suppose that these are the elements, okay, and what is the predecessor and the successor? The predecessor for R is C and the successor for R is E, okay. So that will be stored in order. So if you store in order, that is known as in threaded binary tree. Similarly, if we apply pre-order and store, it's pre-threaded binary tree, and if we store post-order, it's post-order threaded binary tree. In this question we have been asked to define what is a binary search tree. Binary search tree is very simple. In that we will have root node, and the elements which are less than 100 will be placed in the left part, and elements greater than 100 will be placed in the right part, okay. That will be applied for each node. Also we have to write two functions, which is by using recursive method and iterative method, okay. In this question we have been asked to write the functions to illustrate copying of binary trees and testing the equality of binary trees. So firstly we'll write the code, which is node copy node root, okay, and we'll have the node temp here. Firstly to copy a binary tree, see here, if this is the tree which we have to copy, so first we will copy the root node here, and then the left part will be copied and the right part will be copied, okay. So in that way we will recall this statement for copying the right part and the left part, okay. And for testing the equality, first we will check if the roots are null. If it's null, both the trees are same. If it's one of them is null and other is not null, it's not same. And we'll check if the roots are same, then we'll check if the left part of each of this is same and the right part of each of this is same or not, okay. In that way we will continue till the end, okay. That will give us the if the trees are equal or not. We have been asked to draw a binary tree for the expression, and this expression is already in infix expression, so we need not convert it from postfix. So we'll make the expression tree as, first we'll divide it into two parts, and we'll make the plus sign here, and the left part and the right part will be made in a similar way, okay. After making this expression tree, we have to traverse using in order, pre-order and post-order traversal. In this question we have been asked to define what is a graph. A graph is nothing but a combination of nodes which are vertices and the edges, okay. So that's known as a graph. And what is adjacency matrix and adjacency list? Each graph can be represented as by using two methods, which are first one is adjacency matrix. In matrix, what we'll have, this graph is there, and we'll check between each of these nodes if there is a edge. At that time we'll make as 1. If there is no edge in between, like suppose 0 and 3 there is no edge, so we'll make that part as 0, okay. And the direction is also given, right? So there is an edge between 0 and 1, but from 1 to 0 there is no edge, right? So for 1 and 0 we'll make as 0. This is known as adjacency matrix. In adjacency linked list, what we'll have this all these nodes connected together, means there is an edge from 0 to 1, 3 and 2. So what we'll do, we'll make a node here, and we'll insert the next node, which is 2, and the next node, which is 3. So all of these nodes pointed by 0 are placed in a sequential order. Similarly for other nodes also. In the question we have been given with this graph and we have to make the adjacency matrix. So first we will make all these nodes A, B, C, D, E and F in the rows and columns, and wherever there is a edge we will make as 1 and where there is no edge we will make as 0. And the adjacency list is also same. A is having the nodes with B and C, so we will write it in the sequential order. This is very important question. In this question we have been asked to write the methods for traversing the graph, which is breadth first search and depth first search. For more information you can refer to the theory video. I have explained in more detail. In breadth first search, first we will explore one node, means suppose we start from A, we will go to E, okay, we will go to E, C, B and D, okay, that will be mentioning here the adjacent nodes, and we will visit all those nodes, and after visiting each node we will travel the neighbors of that node, okay, like for C the neighbors is G and A, and for B the neighbors is F and D, okay. So we will travel E, C, D and B first, then from B we will travel to F, D, then from C we will travel to G, A, and from G we will travel to E. In that way we will visit all the nodes and we will get the final expression here. This is breadth first search. The next one is depth first search. In depth first search we will choose a node here, okay, suppose that we choose A here, we will travel to C, then we will travel to the next node which is G, then we will travel to E and we will check if A is already traveled or not. If it's traveled we will come back to E, then to G, then to C and to A. Then we will do the same in the other way, like for B, then B to F, like that we will travel all one at a time, okay. So that type of traversal is known as depth first search, okay. Write a C function for insertion sort and by using the algorithm sort the following elements. So we'll compare each element with the previous one. 30 is less than 50, so it will be changing the position with 50. So 30 will be here and 50 is here. Next element is 10. 10 is the least element, so 10 should be placed at the first position. 30 and 50 will be shifted to the right. Like that we will do for all the elements, and the final result will give us the ordered list, okay. This is also very important question. In this question we have been given what is collision. Collision means suppose that we are arranging the elements 44, 73, 17 and 77 in this array, okay. So to arrange it, the last position is seen, means 44 will be arranged in 4th position and the 73 will be arranged in 3rd position. Like that 17 and 77 both have the same position, which is 7. So that is known as collision, okay. So to resolve collision there are two methods. First one is linear probing and second one is chaining. In linear probing what we will have is we will see the next location which is empty, which means after 7 repeating from the first position the 0th location is empty, so we will place 77 there. That's known as linear probing, okay. Explain in detail about static and dynamic hashing. In static hashing we will have the table size fixed, and the disadvantage is that it's not more efficient to resolve the overflow or the collision of the elements. For example, see here these elements which are stored 24, 93 and 45 are stored here, okay. If you have to store the next position which is after 93, if you have to store 83, okay, that will also be stored here, but to get to that we have to travel each of these elements and then we will find the empty location. But whereas in dynamic hashing that's not the case, because the table is not fixed, okay, table size is not fixed. Extensible hashing uses a technique which uses the binary values of the numbers, okay. So the binary value should be stored. See, one's binary value is 0 1, so 0 0 1 will be stored here and 5 will also be stored with 1, okay. And similarly we will have the other numbers list also. What are the basic file operations that can be performed on a file, and explain index sequential file organization. So there are 4 basic operations, which is creating a file. We will create a file by using the name and the mode, and updating a file means updating the values which the file has, and retrieving from a file means the file has a lot of data, right. So a particular word if you want, that retrieval is known as retrieving from a file. Maintaining a file means organization of the data inside the file. In index sequential file organization we have the index values here, which is for the record number, and the address of the record will be stored here. So it's more faster to access the record values and everything will be organized, so the access is more easier. You have to sort the following using radix sort. In radix sort first we will see the rightmost bit, okay. So we will place the elements accordingly. First one is 40, so we will place the 40 with in the 0th location. 37 is having the 7th location, and 05 will have the 5th location. In that way we will store all these elements in this order, and we will take the arrangement of the elements in this order. 40, 21, 05, 37, 27 and so on. So we'll arrange this order in this order, and then we will see the first element, which is 0, 1, 2, like that. Okay, so 40 will be stored at the fourth position, and 21 will be stored at the second position, and so on. Okay, after doing, we'll get the sorted order in this way: 05, then 09, then 18, 21, 27, 37 and 40. Okay, this is the ordered way.